Okay, in this lesson, you are going to learn about how air pressure is shown on these special weather charts that are known as synoptic weather charts. And these are very specialized maps that are used to show us what the air pressure is, and they then also help us figure out certain things about what the weather is likely to do once we know about the air pressure. Now, before we go into looking at the two main tasks that you're going to be tackling in today's lesson, let's first have a think about air pressure itself, because you've already been introduced to this in your last lesson. So air pressure can generally be seen as either being high or low. And you'll have already learned about the idea that high pressure is when there's a lot of air at the surface pushing down on the surface, and that low pressure is when there's a lot of air high in the atmosphere and there's very little air on the surface. Okay, so there's much less air, and we call that low pressure. And you will have also developed the idea about the types of weather that you are likely to find when it is high pressure or when it is low pressure. Now, what we're going to look at today is how this weather is shown on these synoptic weather charts, or these air pressure maps. And let's have a little look at one that is commonly used by the Met Office. And we can see here a weather map for the United Kingdom. And we can see London, Cardiff, Belfast, and Edinburgh marked on that. We can see these coloured symbols here. We're going to ignore them for the moment. These are weather fronts, but that is an area of knowledge that you're going to develop later on in this course in terms of the weather that these things bring. What we're interested in are these lines that we can see on our weather map. Now, these lines are known as isobars. And isobars, if I just show you back to your main document that you'll be working in today, are lines. They're very similar to contour lines, and they join areas of equal air pressure. So there we can see that an isobar is a line of equal air pressure, and it's similar to a contour line. So let's actually apply that on the map that we're looking at. So what does that really mean? Well, that means if I was to travel over to Europe, so there is the Netherlands, there's Belgium, there's Germany, and if I was to drive my car along this line, the weight of the air would be 1,024 millibars. That would be the weight of the air. Now, because that number is above 1,000, we would call this area high pressure. We can even travel further across Europe to a country called Ukraine. Over here, we can see that the air pressure is very high here at 1,028. Now, if we want to find some low pressure, we're going to travel to the west of the United Kingdom, up towards Iceland, and off the west coast of Iceland, we can see an area with an L marked on it, and that indicates this is the center of low pressure. And we can see that the air pressure here is 993. So this area is low pressure, and it's under 1,000. So 1,000 is seen as the kind of cutoff between high and low pressure. So once you're above 1,000, you're starting to head towards an area of high pressure. So Edinburgh, Belfast, Cardiff, and London are now areas of high pressure, or on this weather map. And as we head across into the Atlantic, we can see the air pressure dropping below 1,000 into areas of low pressure. So let's just refresh our memory. We know that these lines on maps are called isobars, and that they mark an area of equal air pressure. So if on an ordnance survey map, a contour line is a line that shows an area of equal height. So if you follow a contour line on an OS map, all along that line, that would be an area of equal height. On a weather map, very same kind of idea, but instead of it being called a contour line, it's called an isobar, and everywhere along it is the same air pressure. And that air pressure is measured in millibars. One final thing to introduce you to before we have a look at an example. How far these lines are apart or together. So for example, here we can see they're quite far apart. Here we can see they're closer together. Tells us about how quickly the wind will be traveling. In a similar way, on contour lines, when contour lines are close together, we have a very steep slope, and when contour lines are very far apart, like over here on the left-hand side, we would have a very gentle slope. Well, with wind, it's the same. When the lines are close together, we have a strong wind, and when the lines are apart, we have a much gentler wind. We can finally also work out something about wind direction. Okay, So before we go on to wind direction and all of those things and bring them together, let's have a look at the task that I'm about to ask you to do. And then as I go through the next bit of the lesson, you can follow each little part of my lesson and answer the questions accurately. Okay? So, just letting it load up. Here we have a similar weather map, but in this time we don't have a map of Europe underneath it. All we can see is the isobars with their air pressures marked on them. We also have these black arrows to help you understand something about the wind's direction. I'll talk more about that in a second. And we've got a big L and a big H to tell us whether it's low or high pressure. Now your first task is going to be to complete this table. Okay, so the air pressure in millibars is, now high pressure, it's going to be above 1,000 millibars. How do we know this? We can tell this, so how did I know? How is the fact that it's above 1,000 millibars shown on one of these maps? Likewise, once you've answered that, for low pressure, you should say below 1,000 millibars, and then you can tell this because, and you should give an explanation. Okay? Next thing, the wind speed. Now, in high pressure, it is low. Okay? So why is the wind speed low? Well, I can tell you right now that when the isobars are far apart, the wind will be a lower wind speed. And when they are close together, like we can see over here in the low pressure, you can see the lines are actually very close, we have a high wind speed. So what I'd like you to do there is low, we can tell this because, so the wind speed is low because, and you're going to be writing the isobars are far apart. And then give me the opposite of that for low pressure. So what's the opposite of a low wind speed? Well, it'd be a high wind speed. But how do you know it's a high wind speed in areas of low pressure? Okay. The wind direction. So what do we know about the wind direction from these weather maps? Just looking at the wind. Well, this is your first extremely important bit of knowledge. Okay, wind direction is determined by where you are on this weather map. But there's one thing you need to know before that. You need to know that wind always travels in a clockwise direction in high pressure. Now I'm using my cursor here over the ISO line to show you what clockwise would look like. The arrows on the map also show you what clockwise would look like. Basically the hand of a clock as it's ticking round, and it follows the isobar. So in high pressure, wind always circulates in a clockwise direction, following the lines of the isobars. And that is actually what you want to say in the answer down here. So scroll back down again and tell me that in high pressure, wind travels in a clockwise direction. Now, in low pressure, you want to obviously tell me the opposite, because in a low pressure area, wind travels in an anti-clockwise direction, following the isobar. So we can see the arrows here. The wind would be going this way. Now that is against the direction that clock ticks, so that is anti-clockwise. Okay, so sorry, just let me scroll back up a bit. So where are we so far? We understand something about the air pressure in millibars from the map. We can tell something about the wind speed. We can tell something about the wind direction because it's traveling in a clockwise direction in high pressure. And over here, it's traveling in an anti-clockwise direction. And you must also remember to say, following the direction of the isobars. This is where we start to get to more difficult points. Temperature, because temperature is actually governed by other things other than what we can see on these weather maps. So let me just have a little look at the map and I'll tell you about high pressure and the possible temperature. In this area here, the temperature is going to be actually dictated or governed by the time of the year. Now, in high pressure, because there are no clouds in the sky or very few, in summertime you're going to get very hot weather because there's nothing to prevent the heat from the sun getting to the surface because there's a lack of clouds. So in summertime, in areas of high pressure, you're going to get very warm temperatures. However, in wintertime, the flip happens. Because there is a lack of clouds in wintertime in high pressure, there's nothing to insulate the planet. So all of that heat built up during the day gets lost at night time because there are no clouds, because high pressure means no clouds. So in this area of our weather map, if we were to see this high pressure, we would assume that if it was summertime, it's going to be very hot, but if it's wintertime, it's going to be very cold. Now, low pressure has the similar thing. The temperature is determined by the time of year, and clouds are the key factor here. So in low pressure, we have lots of clouds. Now, in summertime, what clouds are doing is they're absorbing and reflecting heat from the sun. So in low pressure areas, it's going to be cooler in summertime because the clouds are stopping the heat getting to the surface, or some of it. However, in wintertime, the clouds do the opposite. They actually act like a blanket and trap the heat. So in wintertime, low pressure will actually probably bring slightly warmer weather because of the effect of the clouds. So down here, you want to be telling us this about the temperature in the area. Cloud cover, I've now explained. But let's go a little bit further. Why are there no clouds in high pressure? Okay, so if I was wanting to explain that it's high pressure, so there's no clouds, I'd want to say why. And there's no clouds because the air is sinking. And when air is sinking, that means the moisture is all at ground level. And if the moisture is at ground level, you can't have clouds forming, because clouds form when air is rising and the moisture is going up the way because of evaporation. So what do we say here? There are no clouds or few clouds because the air is sinking, and therefore clouds can't form when air is sinking. Now in low pressure, the opposite happens. Air is rising, and that's how we end up with low pressure on the surface. And because we have rising air, moisture goes up with that rising air and forms clouds. So that's what you'd write here. And finally, rainfall. Now, the idea of rainfall is actually more to do with weather fronts, but we can think a little bit about rainfall and air pressure because it's all to do with clouds again. In high pressure, because we don't have any clouds forming, or we have very few clouds forming because the air is sinking, it's unlikely there's going to be much rain, because to have rain, you need clouds. And the opposite is true for low pressure. In low pressure, you have air rising, and therefore clouds are forming. And of course, if clouds are forming, you're more likely to have rain. So low pressure is more likely to result in rain. Right, what I do now is pause. If you've missed any of these boxes, go back through any point you might have missed. It's not just I want you to describe what you're seeing in this weather map and how you know that weather here in this area of the weather map would be different from here. What we're now going to do in the second part, assuming you finish this first task, is we're now going to look at how can I tell a difference in weather, for example, between Britain, the weather Britain's getting right now, and maybe Iceland. So if I was looking at the weather right here where my cursor is in the middle of Iceland, what type of weather would I expect to get? And how would I know that weather using this map? Likewise, if I was sitting in London, what type of weather would I get? And how would I know that? And there's a little bit extra you have to add here, because especially with wind direction, it's not just about knowing whether it's clockwise or anti-clockwise. You can actually now start to work out the actual wind direction by looking at the isobar. So let's move on to that second task and have a think about what we're going to be doing. So in this second task, you have a map of Europe, and we have Glasgow marked over here. And we can see over here we have an area of low pressure, or the center of low pressure. So Glasgow is very close to that center of low pressure. And I've even added some annotations and some little arrows to help you think about the likely weather in Glasgow. Over here we have Frankfurt in the middle of Europe. It's very near the center of high pressure. I've added some little arrows here to give you some information, as well as some annotations to the map to help you answer this question. And the question says, using your knowledge of air pressure from the previous task, that's the one I did at the start of the lesson, describe and explain the likely weather you would find in Glasgow and Frankfurt. Right. So, first of all, you need to tell me what the air pressure is in Glasgow. So, is it high or is it low? So you need to look at the weather map, and you have to do the same for Frankfurt. Is it high or low? Okay. to explain whether it's high or low, you need to tell me what the air must be doing in Glasgow. So if you have quite correctly identified that Glasgow is low pressure, that must mean that the air is rising around Glasgow. Likewise, if you've correctly identified that Frankfurt is in an area of high pressure, that must mean that the air is sinking here. Now, once we know that, the wind direction is the one thing where I need to give you one final bit, and you can do the rest yourself. So we know in Glasgow that it's low pressure, so we know that the air travels in an anti-clockwise direction. That is something I've already told you in this lesson. So if you look at my cursor, it's circulating round, showing you the direction the wind will be traveling. Now if we look where Glasgow is, and we know that the air is traveling following this isobar, because that's what winds do, that's what these isobars actually show us, they show us the wind's direction, we can see that the air must be coming up from down here in an anti-clockwise direction and traveling up here. So the wind direction in Glasgow would be southerly, would be coming from the south, heading to the north. So it's a southerly wind. And the reason we know this is because that winds travel in an anti-clockwise direction following the isobars. That would be our explanation. And that's what the question asks you to do. Now, to do Frankfurt, all you've got to know is the opposite, that wind travels in a clockwise direction following the isobars. So now I'd like you to write down in Frankfurt, the wind is traveling from, and tell me what direction it's coming from. And how do you know that? Well, your explanation is the same as with low pressure, because wind follows the direction of the isobars in a clockwise direction. And that's, of course, because Frankfurt is in an area of high pressure. Okay, that's me done the first two bits for you, air pressure and wind direction. I'd like you to do, what's the likely wind speed in Glasgow, and how do you know that the wind speed is going to be what it is? Likewise, do the same for Frankfurt. What's the likely cloud cover in Glasgow going to be, and how do you know this? Likewise, what's it going to be in Frankfurt? What's the likely temperature going to be in Glasgow? Now remember, you're going to have two answers here because it really depends on what time of year Glasgow is in. Is it winter or summer? And do the same for Frankfurt. And finally, could you tell me about the likely rainfall? Once you've completed this task, can you just hand it in?